I'm going to have to fill this in. All right, so if the string compare of the cur employee name, comma, the key is greater than 0. So normally what you can think of is this is like greater than 0 is like inserting a greater than sign in between these two guys. And so imagine if the name of the current employee we're at is greater than the key. So if our key is smaller than what's in the current name, where would we go in our tree? So if the value we're looking for is less than the current value in the node, where do we go? Do we go to the left or to the right? We go to the left. So if it's greater than 0, if this thing with the comma is greater than 0, then that means we need to go left. And as long as you keep consistent, you should be okay. If you're inconsistent, then you're going to have a really bad time. So we're going to go left, which means that cur emp is now equal to the cur emp what? Pretty easy, right? All right, if we're not the case, well, we could be equal, right? Why are we not equal? Okay. So if it's not equal, then we can go right. The wall just creaked. I think it's going to fall on me. Good thing I just bought health insurance. Oh, sorry, life insurance. I feel like a really bad beggar commercial. All right. Well, that was easy. All right. That's a Staples thing. All right, so this is how we check if value is already in the map. So that means that all the way down here, the value is not in the map. Sad. All right, so because the value is not in the map, we have to actually go and find and insert the value the way we would do normally inside the binary search tree. Fun. You guys are super excited about this, I can tell. All right, so what we need to do is we need to get the current employee back up to the root. You know what we can do? Since we're just inserting into a binary search tree, let's just go ahead and create an insert method that takes in a node. That would be so much easier. And then we can do this all recursively. So what we're going to do is we're going to say map root is equal to insert. There we go. Insert. That was wrong. All right. The root, and then we're going to pass in. Unfortunately, this is like a different insert than we've done before, because this is going to be the insert of a key and a value. So we're going to have to do 2 values rather than just 1. So a key and a value is being inserted into this map. And unfortunately, this means that we need to make a new function. So let's go up to the top, and we'll go ahead and put the prototype of this function down. Yeah, what's up? What's up? Wait. What's up? Yeah. Not equal to 0. Yep. So the reason why is because I know that I want to make sure that this value is not, like, I want to make sure the key I'm looking for is not inside my current tree. And so what I'm doing is I'm at some node, and I want to check to see if the key at that node is equal to the key I'm given. If it's equal to the key I'm given, then I'm never going to go, I'm not going to be in this while loop. I'm going to leave this while loop, and I'm going to go ahead and go into here. But if it's not where I'm at, if the keys are not equal right now, then that means that it's not going to be equal to 0 when you do the string pair up at the top, where the cursor is at, kind of. So the reason why I put this if statement here is because if it's not equal, then that means it's somewhere in my, it might be somewhere in my binary search tree still. And so I need to go through the binary search tree the way you normally go through the binary search tree. And how you go through the binary search tree is if the value you're looking for is less than some value, you're going to go in one direction. And if the value you're looking for is greater than the value, you're going to go into the other direction. And so what we're trying to do is we're trying to check to see if this name, when it's compared against the key, if this is greater than it, we're going to go to the left, which is that direction for you. And if we're less than, we're going to go to the right, which is that direction. So this if statement is inside the while loop, and because of that, we're going to go into this anyways. Yeah, so the idea is that as long as these values are not equal, we'll keep doing this if statement. So while this is happening, do this thing here. If I had a semicolon here, then that would stop me. That'd be really bad. Don't put a semicolon there. But anyways, yeah, I'm just going to continue on. This is going to be employee star insert. It's going to take an employee star, and this is going to be like the employee we're looking at. And then it needs to take in the char star, which is the key, and it needs to take in the int, that's the value. And really I can put this, oh, I heard someone has a question. What? Yeah, what's up? Yeah, so we're going to have two Alice's then, which is great. That means that if you have 20, you can have up to 32 different Alice's working in your company, because you can change the capitalization in 32 different ways. Because you can have all lowercase Alice, we get all uppercase Alice, and then we can like have different combinations of uppercase and lowercase Alice, because those are going to be different. We can go ahead and do that silly thing after I'm done with this, hopefully. So it's going to take in a current employee, it's going to return the employee after doing the insertion, and hopefully everything will be good. And so we're going to go ahead and put that down here. We're going to work on this function. Oh, boy. All right, so this is going to be recursively done, and since it's recursive, what do we need to do? All right, cool. If that's not ingrained into your brain by the end of this semester, then I failed as a CS1 teacher. All right, so what's going to be the base case? What do you think the base case should be? So if the guy is not null, all right. It's always a good first guess. Yeah, if it is null, I think what we want to do here though. Because if it is null, what we can do is we can create this employee and say, like, so imagine our tree is empty, so that means this is going to be the root of our tree, so we just create our node, return it, and we're good. Like, that makes sense, right? Yeah, so we're going to do if it is null. And what we need to do now is we need to create our employee. So yeah, sure. Actually, if I wanted to, I could just use this curve. Well, whatever, we won't worry about that. All right, so what we need to do is allocate the memory. So it's going to be employee star malloc, not malloc, calloc. I like calloc better. 1 comma, and needs to be the size of what? With a star? Okay, good. So with this rent employee, I'm going to go ahead and set the value or the salary equal to the value. With this rent employee, I need to update the key. What's the key inside the employee called? Do you guys remember? Yeah, its name. So I need to somehow like store this. What do I do? So I should string copy, but the issue is name doesn't have any value associated with it right now, right? It's like a null pointer. So I need to actually allocate this first. Ew. All right. I know, it's like your most favorite thing in the world. So I'm going to go ahead and give it a length equal to the key plus 1. Why am I doing the length of the key plus 1? The null terminator, that's correct. And what's going to be the size of this? All right. And so is there anything else I need to do? I actually need to do the filling. So strcpy. And what do I put in the order here? Do you guys know? Yeah, I need to do ret employee name first, and then the second thing is going to be the key. And so now I've made my employee, and I can return the ret employee. And so that's it with the base case. And now I have to handle the non-base case. So in the non-base case, I need to either go left or right depending on what the key value is compared to whatever the current employee is. So I know this is like your favorite thing in the world. So what I should do is I should check the comparison. I should string compare the key with the current employee's name. And so let's just go ahead and try to think about this again. If I have the 0 over here, it's like putting a less than sign here. And so if the key, or greater than sign, because I'm doing a greater than first. If the key is greater than the current employee's name, which direction would you go? So if the value of the thing is less than the value we're trying to insert, which direction do you go? You go to the right, because this value here is greater than what's in this node. And if the value is greater than what's in the node, then that means you're going to go to the right-hand side. So we're going to go right. I coded this backwards from where I did the first time. But this is going to be a go right case. And so what we do is we have to go right. And how we go right is we say the current employee right value is equal to insert the employee, the key, and the value. And then otherwise, what do I do?
You go left.
Yeah. So otherwise I have to go left. And it shouldn't be that this is ever equal, because I should have already checked to make sure that this person doesn't exist. If this is now equal, then something fishy has gone on. Maybe this has done some concurrent thing, and we have some multiple people accessing the data structure at the same time. But if we have a single person, if this is like run on a single core processor, and there's like no multi-threading going on, we shouldn't have any issues. So we should just be able to go left. This is not thread safe. For those of you that know what that term means. And so what we should do at the end of this is whatever's happened, we need to return the current employee, because he's the person that's going to be, he's the pointer that should be for whatever this left or right value is. All right, and this is it, or at least it should be for the insert. So where did we check to see if it already existed? We checked it in this function here. If we ever found that the value already existed, then we went ahead and just updated the employee and returned. Otherwise, we do the insertion. So basically, this is like a gatekeeper for the insertion function. We're never going to insert. You should never insert without first checking to make sure that this person already isn't in there. And this is what we're doing to check to make sure that person's already not in there. If the person is already in there, we update the value, and then we return. We don't continue on. We just stop here. It's like, nope, we're done. I quit. I'm leaving. All right, so is there any questions right now on the insert function? Well, the set, I guess? Yeah, what's up? Scroll down, sorry. Yeah. Oops. So I need to make the memory for this name, because right now the name is, it's supposed to be a pointer to a section of memory, but the thing is I haven't actually put anything at that location. Calc filled it with zeros, and because it's 0, it's basically a null pointer. For all intents and purposes, for most systems it's going to be a null pointer. And so I need to give it an actual pointer. And so in order to actually give it a pointer to something, I need to do an allocation of some sort. This is like back all the way to the dynamic memory lecture. And so one of the ways to do an allocation is to go ahead and do the calc. And so what I do is I do string length plus 1, because this is supposed to be a string, and everyone, you guys should all be familiar with the fact that strings need to be null terminated. So I say, find out how long that key is, add 1 extra character to it, and that's how long this name is going to be. And now what I do is, after do this allocation, I take that pointer and I fill it with the memory of whatever's in the key value. And so now whatever was stored in the key is now being put into the name. And so now if I ever look for the employee named Alice, Alice should be this ret employee because the key value should have been Alice, and Alice is now stored in name. The key is the employee's name in this case. That wasn't made entirely clear, but if you look at the, I mean, it's not entirely clear here, but if you look up at the structure, the salary is the value, and then the name is what you sort on / the key. All right. Oh, while I'm up here, let me do this one thing. Otherwise, this is not going to work. I mean, it's probably not going to work anyways because I'm coding it, but you know, it's going to be a little bit more correct now. All right. So let's go ahead and do. We're not not doing delete, so we'll kind of like ignore it for now. So what I'm going to do for this guy, oops. It's going to return 0 every time because it's not going to read any values. If I happen to time at the end of class, I'll work on that. Alright, and now let's go ahead and do the get operation, because I think the get is pretty easy. We'll be able to see this hopefully working within the next 5 minutes. So, what do you guys recommend doing for getting? Yeah? Yep. So I'm going to go ahead and walk through the binary string, or binary search tree. And we do the binary search tree by first creating an employee node. That will be basically the current employee we're at. So if the value isn't in there, I should go ahead and like return some bad value. So if it does not exist, then we return a bad value. And so the current employee is going to be initially set to the map group. And yeah, you guys are probably like, what the heck is bad value? I'm going to go ahead and define that up at the top of the code. So what I'm going to do is I'm going to have the current employee as the root, and then what I need to do is I just need to go ahead and check to see if that root is equal to my employee, and if it does, I can return the value. Otherwise, I can begin walking my way down until I hopefully eventually find the value. If I don't find the value, then, well, shoot. That means that the person doesn't exist. All right. So while the current employee is not equal to null, and the current employee key is not equal to the key we're given. That's how I do that, right? Yeah. I'll do that one moment. I'm just going to lay down the structure a little bit so that you guys understand what's going on. Alright, so this is going to be the structure. I need to go ahead and do my walking in here. And so what's going on is if my current employee is not null, then we're good so far. That means what I can do is I can check to see if this key is not equal to the other key. If they're not equal, then I'm going to keep walking until eventually I hit null. And now down here what I'm doing is I'm checking to see if these keys are equal. What I really should do first is check to make sure that this current employee is not equal to null. And then if I check that the value is not equal to null, I really don't even need to do this key check because the key check should always be true because we're outside of this loop. But anyways, I do need to put that the current employee is not equal to null in the check here, and then I can return that employee's value, and then otherwise I can return that value. There's a question there in the back.
Oh, the yellow one?
No. So do you want me to do that right now? I can do that. Yeah, let's do that first. So let's go ahead and come up with the bad value. So at the top, what I'm going to do is I'm going to say that pound define bad value, we'll do -1. If you're like making negative money, that means you're paying someone to work, and I think that's kind of shitty, so that's a pretty bad value.
Me too, thanks.
Alright. So what I should do here is I should check to see that this is not equal before doing this check. But as someone pointed out, I can't do this with strings. This is no. I need to actually do string compare. And so how you check two values are not equal is what? Yep. And if two values are equal, then what? Yeah. Alright, so I'm checking to see the value, if it's equal to 0, we're good. I'm checking to see if this value is not equal to 0, and if it's not equal to 0, we're going to do the walk. Alright, so this is good so far, but now I need to do the walk thing. So, if str cmp the current employee key that was given to us is greater than 0. So let's try to figure out what this means. Let's go ahead and replace this greater than sign there and try to interpret if we need to go left or right. So if the employee's key is greater than the current key that we're at, wait, no, I'm saying that backwards. If the current employee's key, so if the node that we're in, if its key is greater than the value we need to find, where should we go?
Left.
We need to go that way. Because the thing is less than this value here. If we're looking for 4 and this is a 10, then we need to go to the left. So that's what's going on here. You guys are really good at this. Very helpful. It's not being sarcastic, even though I laugh. Alright, I'm just like really bad at expressing gratitude, I guess. Alright, so cur employee is equal to cur employee left. And then otherwise what we need to do is we need to go right. Plus now I get to blame you guys if this doesn't work. That's how gratitude works in an employee boss situation, right? I don't know. Alright. You're right. That's a weird one. Alright. So hopefully this is all correct. It probably isn't, but you'll never know until you compile. I don't even know what I call this. I think it's like math exercise or example. Alright. And wow, that was good. Okay. So it's supposed to be salary, not value. Oh god, there's going to be a ton of these. And this isn't supposed to be key, this is supposed to be name. Oh my god. I don't want to replace all keys though, because, yeah, alright, key, oh wait, arrow, key, okay, arrow, value. Oh, are you kidding me? It was just that one function, but like there's a lot of errors, so let's see. Alright, remove this conflicts. Let's see. Oh no. Remove actually might be like used somewhere else, somewhere. So I might need to change that. Let's see, what other errors do we have? Man, a lot of them. It really does not like this. Incompatible pointer types. Dude, that's really bad. We need to figure out what's going on there. Incompatible pointer types is occurring. This is an employee star. Wait a minute. 104. Left is equal to insert. Insert returns a employee star, and in current employee, the left should be employee star as well. Did I do that wrong? Did I do insert wrong? Oh yeah, you're right. I mean, yeah, it's going to let me have the infinite loop. That's not the issue that we're having here, but that is a very good point. So that's supposed to be cur right, because I need to go into the right subtree, and that's supposed to be cur left, because I need to go into the left subtree. Incompatible pointer types, though, it doesn't like the assignment as well, definitely. And that's at line 104 and 93. It also doesn't like 79. Why is that? Did I like make something weird up here? So employee star insert, no, it's an employee star, and that's employee spelled correctly. Alright, I'm gonna try compiling it. It's gonna freak out. I didn't do what? Oh. That's so dumb. Alright. Do I need to do this as well? That's like really silly. Alright. Does it actually not do that correctly? Ew. Does that mean you can't have circular dependencies?
Yes.
Whoa. That's so cool. Alright. Hey, look at that. We're getting a lot of other things now. Alright.
How come this is my line?
Line 36, 41.
Oh yeah. 40. Wow. I did not copy and paste. You can't prove anything. Alright. Alright, that's pretty good. Only 3 errors. That's like... Yeah. Alright, so it doesn't like the remove. So I'm going to go ahead and like change the remove because I think that this might be used elsewhere inside the standard library. So I'm going to go ahead and change this to my remove instead. Or remove map. Ooh, remove map sounds like a really good use. Alright. Yeah, I really don't like that. Alright, so yeah, it's because apparently remove is like in this weird file name thing, and yeah, that's disgusting. Alright, so let's go ahead and just run this and have it not work. Whoa, Bob is making -$1. That's probably not good.
Well, that's because of the fact that you never actually initialized Bob at the very beginning.
Oh, so what does that mean? If I don't initialize Bob, what should he return? Yeah, he integer overflowed. He's now making an infinite amount of money. All right. So if we wanted to fix this, what can we do? But what if Bob's not employed? All right. So let's go ahead and do this. This is like really horrible, and this is probably not what you should do. Int Sal. All right. So Sal is equal to get Alice. You know what? Let's go ahead and just put this into a function because that's going to be better. We're going to go ahead and print employee Alice, comma, map. And then we're going to print employee Bob, comma, map. And then we're going to make a function for this. So it's going to be a void function. It's going to be print employee. And what we're going to do is we're going to take in, guess what we're going to take in? Alright, and so now we need to put this function down below. At the very bottom. And so what this is going to do is int sal is equal to the map get key. If the sal is equal to a bad value, oops, I didn't do that. Then this means that the employee isn't actually employed. So what we're going to do is we're going to print out %s is not employed. And then we're going to go ahead and say key is the value there. Employed. There we go. Words are hard. All right, else. What we're going to do is we're going to say printf. %s is making and hopefully that doesn't screw up everything. We'll see. All right, so this is going to be very simple how you print an employee that's inside the map.
You never said what %d is.
All right. Sal. Alright. When Harry met Sal. Alright. And it's still probably wrong, but that's okay. Just let me be wrong a little bit. No, but not too wrong. Alright. And biscuits. Not yet. I've been doing way too much Java programming. Alright. There's no such thing as switch Java programming. Whoa, that compiled. Oh no. Alright, I'm gonna fix that, and it's gonna be like the dirtiest fix you'll ever see.
Delete them.
It bothers me otherwise. There you go. Alright. So this is how you do math. It's not that bad, right? You guys could all do this on your own. I trust you guys.
What?
Alright, I'm going to go ahead and just, I guess for the sake of, I don't know, flexing my muscles, I'm going to go ahead and try to work out a deletion. You guys can go ahead and try to like watch me do it and then give me suggestions and how horrible I'm doing or something like that. I don't know. So let's go ahead and do that. So this is the deletion. What we're going to try to do is at the very end, we're going to try to delete Alice, and then we're going to try to update. So what we're going to do is we're going to remove Alice, so remove map. We need to pass in a key. What the heck? All right. No, I don't want to do that. Actually, we should do that because I'm wasting a whole bunch of memory here. There's a huge memory leak. But what we're going to do is we're going to remove map, and we're going to remove Alice. Alice is getting fired. And then what we're going to do is we're going to print out if Alice is employed or not. Hopefully, the answer will be no. Has payroll gone through? All right. So let's do that. So what we need to do is obviously change this now, because now we need to take in the char star, which is the key that we're removing. We need to find Alice inside the thing, and then we need to remove her. So let's try to find Alice, I guess. Well, the first thing we should do is make sure that Alice doesn't exist. But if she doesn't exist, we're going to be returning 0 anyways. So let's just do the normal thing. I don't want to do that. Where is the bit code? That's like super tempting. So the issue though is that this is a binary search tree removal, and what do we need to do with the binary search tree removal? Quick guys, pop quiz. Yeah, we need to make sure that we have the right number of children, right? If we have 1 children, we can just simply move things up. If we have 0 children, we don't care. But we have 2 children. I mean, we don't have to worry about the 2 children case, right? We know Bob that is like on one side and there's no one else on the other side, so removing Alice should be really easy, but you know. All right. This is not fun for me. So what we're going to do is we're going to say, I'm going to go ahead and make a new function. I'm going to make a map root is equal to remove whatever. Oh no. I feel terrible. Alright, but I also need to check to make sure that this person actually exists. So what I'm going to do something really dirty. If the person doesn't exist, I return 0. So I'm going to cheat. This is not something you should ever do. Because I am a bad example. Alright, so what we're going to do is we're going to check to see if when we get this element, if we end up getting the bad value. If we end up getting the bad value, that means that person shouldn't be employed. And if we get that fact that that person shouldn't be employed, that means that person's not in here. So what we can do is we can say this person doesn't exist, or we're going to return 0. So the reason why you shouldn't do this is because, hypothetically, what if someone does end up coming to work for the company, and they end up paying the company while they're working, for some reason? I don't know why. So it's really funny, because then we'll never be able to fire that employee, which might be a good thing, because that means we'll keep making money off of them, right? But anyway, so this is why it's bad, is because this is bad if the employee does exist and makes bad value amount of money. Alright. Oh, so that's really upsetting, but it's honestly the most easy thing that we can do. So what we're going to do is we're just going to go ahead and make this remove 2 function, and everything will be hunky-dory. Remove 2. What this is going to take in is it's going to take an employee, it's going to return employee star. And it's going to take in also the key. So there's actually this really funny, dirty thing you can do when you're doing removal in the binary search tree. And I'm going to go ahead and show it off right here. It's pretty cool. It doesn't necessarily work in balanced binary search trees though, but it does work in this one, just because of how we're doing it. So what we need to do is check to see if the current employee is equal to the one that we're trying to remove. So if the strcmp of the emp name is equal to the key, that means that this is the person that we need to remove. In which case we need to go ahead and do the cases. So case 1 and 0, or and 2 I should say. Well, I'm going to say case 0 and case 1. So this is the 0 children and the 1 children case. So if the emp right is equal to null, then we can go ahead and do something really simple here, and we'll end up returning. And what we're going to return is the emp left. But we can't do that. Yeah, we can't do that. Alright, I'll fix that in a little bit. Alright, so how many things are wrong with this small segment of code here? 4. Alright, let's go over them. So does everyone want to tell me the first thing they notice that makes them cringe? Yeah, what's up? Yeah, so that's bad. This is use after free. So let's go ahead and fix that. So he's saying that this is going on here, and this should not go on before we free the employee. We should free it first, and then we free the employee. So that's better for you? Alright, what's up over here? Okay, so what if left doesn't exist? So I'm about to reference null because I'm assuming that employee exists, right? So employee has just been freed, that's not allowed. So we're not allowed to dereference left, or dereference employee, sorry. What I have to dereference instead is I can't dereference this at all. But what I did do was I stored it before doing all the shenanigans. So what I can do is, instead of doing this, is I can just return the retname. So is there anything else that makes you cringe in this? Out of curiosity? Yeah, okay, what's up? Uh-huh. Yeah, that's correct. So let's think about that. What if employee left is equal to null? I'm probably not going to finish this, but we'll do a .cam thing just to go ahead and go over or revisit the removal inside of BST. So you're saying that we have this guy here. Imagine that we have some pointer that's coming up from here. This is our parent, and this is our current employee. And then what we just did was we checked that the right value was equal to null, right? This is null. All right? And you're saying that what if this is equal to null as well, correct?
Right. You made an assumption that that isn't null.
So,
and you said that it can be either 0 or 1 children.
Yeah. What happens in this case here? Like, what does this end up doing inside the BST? What should this end up becoming? And so P ends up pointing to what? Isn't that like taking this guy here and moving it here? So we're checking right. Yeah, so this is the one trick. So we're checking right to see if it's null. And if it's null, then that means that we're in the case where we're either 0 children or we're in the case where it's 1 child. We could also be in this case here, where this is the left child, right? Where this is not null. And this could go on further. So we're in either this case or this case. And so if we're in this case, what we want to do is what? Yeah, we want to move left child up. So left child goes here, and then we have whatever the pointer stuff was pointing to, and this is now gone. And so that's kind of what we're doing here as well. If the right pointer is ever null, what we do is we take this guy here and we move it there. And how we move it there is what we return it. We say, hey, we're not using current employee anymore. We freed current employee. Now use this left child instead. And so that's why we're returning. We're saying whatever was referencing this, use this element instead, because this element is the correct one to use. And parent will be like, okay, I'll use it. Or if this is the map that's pointing to the root, the map would be like, okay, this is my new root. And so if we're in either one of these two situations, this will end up working out. The only time this doesn't work for the one child case is when? Yeah, when the child's on the right and this is null. So how can we check that? Let's go back to the code real quick. And technically we're over time, but we'll just go ahead and finish doing this one case, and then I won't be able to obviously run it. I actually can't run it. Holy shit, that's awesome. All right. Even though this is like horrible long. Yeah, we should check the other side. So I'm going to go ahead and just copy this, paste it, change this to left, change this to right, and then we pray that this works. Oops, compiled, good. Ah, shit. All right. Well, I didn't make you remove two. If you guys want to go, you can. If you guys want to stick around for just a little bit while I finish this off. Alright. And it works! Even though we're not traversing a tree. Why does it work even though we're not traversing the tree? Yeah, because Alice is the root. If Alice wasn't the root, then this would not work. If I tried to remove Bob, then it wouldn't work. Well, actually, it wouldn't work if I removed Alice first. But if I tried to remove Bob, you'll see that it won't work. You guys can go on.